Hey kiddos, today we're going to be talking about reverse operations. So what we're going to be doing today is solving for x by looking at what's been done to x and then doing the opposite of that, working backwards to get back to x by itself. So let's look at some examples of opposite operations. Really intuitive. The opposite of addition is subtraction. The opposite of subtraction is addition. And then multiplication and division will undo each other. The one that a lot of people don't really think about is the opposite of a square, which is a square root. So getting rid of a square would be a square root. Okay, let's look at how we're going to apply these. So again, in algebra, we're working backwards to solve equations, which means that if we want to solve, we need to figure out what x has to be to make the equation true. Okay, so our first example, we're asking ourselves, looking at this problem, what is the opposite of adding 3? Because our statement says in the equation x plus 3 equals 17, we need to be thinking about how do we get rid of that plus 3? What would be working backwards? Okay, so we're going to treat this like a balance. So x plus 3 equals 17 is a statement. The equation is literally telling us that they're equal to each other. So the left side, x plus 3, is equal to the right side, 17. So if I do anything to the left side, I have to do the same thing to the right side in order to keep things equal. So if I'm working backwards, I'm going to subtract 3 on this side. That means I'm going to also subtract 3 on this side. I'm going to keep my workspace nice and neat by drawing a line here to separate my steps. These are going to cancel out because they're opposite. Plus 3 and minus 3 cancel each other out. X is the only thing left over on this side. And 17 minus 3 is going to give us positive 14. Okay. Now, if I wanted to check my work, I could go back to what I know about evaluating equations, and I can take that 14 and plug it in to the original equation. So if I wanted to check my work, instead of x, I would plug in 14. And then I keep everything else the same. And then I just evaluate if this is true or not. 14 plus 3 does in fact equal 17, so we know we did this correctly. Okay, next example. We have 4x equals 20. That's our statement. Remember, when you have a number right next to a variable, that means they're being multiplied together. So this literally says 4 multiplied by x is equal to 20. I'm going to start by setting up my wall. And then we ask ourselves, what is the opposite of multiplying by 4? And it's dividing by 4. Now, to divide, we're going to create a fraction. So we have 4x in the top. We're going to divide by 4 on the right side as well. And then we're going to divide our steps. The 4's cancel, so x is the only thing left over. And 20 divided by 4 gives us positive 5. So again, to check my work, I go back to the original equation and I plug in the value of x. So 4 instead of x, we plug in 5 using parentheses so it doesn't look like 45. And then evaluate. Is 4 times 5 equal to 20? Yes, it is. So that means that we have 20 on both sides, so we did this problem correctly. Okay, our next example. X divided by 5 equals 10 is our equation statement. So x is divided by 5 equal to 10. The opposite of dividing by 5 would be multiplying by 5. I'm going to multiply by 5 by using parentheses. If I do it on the left side, I have to do the exact same thing on the right. So here, the x is being multiplied by 5, but before that can happen, this 5 is going to cancel with the 5 in the denominator. So x is left over, and on the other side, 10 times 5 is going to give us 50. And then again, just a quick check of our work to make sure we did this problem right. We replace x in the original equation with our value that we found for x. So 50 divided by 5 equals 10. And then we determine if that's true or not. 50 divided by 5 does equal 10. So we did this problem correctly. Okay, next problem. X minus 7 is equal to 8. x minus 7 is equal to 8. So we ask ourselves, the opposite of subtraction would be addition. So the opposite of subtracting 7 would be adding 7. We're going to add 7 to both sides. Separate my steps to keep my work nice and neat. The 7s are going to cancel. So x is equal to 8 and 7 make 15. And then to check my work, I'm going to plug it into the original equation. 15 minus 7, does that equal 8? 15 minus 7, it does equal 8, so we did this correctly. Okay. Now, our last example for today is having to deal with square roots. So let's look at a problem where we have some squares. We have x squared is equal to 100 and x squared equals 36. So remember that the opposite of a square is a square root. So square root is a symbol that looks like this. If I do it on this side, I'm going to do the same thing on the other side. And then remember, when you square root something, all it does is it gets rid of that square. Okay, so x is the only thing left over on this side. And then we have to ask yourself a really important question. What is the square root of 100? So there's a couple ways you can figure this out. You can think of your multiplication tables. Remember that squaring something means you multiply it by itself. So what number times itself equals 100? Now, some of you have this memorized, and that's great. You can think of 1 times 1 is 1, 2 times 2 is 4, 5 times 5 is 25, 6 times 6 is 36, 8 times 8 is 64, until you get to 100, and you'd find out that the answer is 10. But 10 is not enough. So let's look really quickly at why. 10 times 10, that's going to give us the value of 100, and we know that. But then we have negative 10 times negative 10. And negative times negative makes it positive. 10 times 10 also gives us positive 100. So not only does positive 10 work, but negative 10 works as well. So there's a couple ways we can write the answer. You can write this symbol right here, which means plus or minus 10, or you can actually just write it out, 10 or negative 10. Okay. Now, because we don't know which one x is, we have to include both. Now, similarly, for the next problem, x squared equals 36, we're going to do the same thing. We're going to take the square root, and x, because the square goes away with the square root, equals, and hopefully you know that 36, the square root is 6, but because we don't know if it's plus or minus 6, we're going to include both. And again, you could write that out, 6 or negative 6. Okay, and that's all for one-step equations. Remember, all you do is work backwards by undoing the operation that's already been done. If they add, we subtract. If they multiply, we divide, and so on.